video that way.
All right, inference about means. The central limit theorem states that if a sample size is large enough, the sampling distribution model of sample mean from a random sample is approximately normal, regardless of the shape of the population's distribution.
Did you just say sample? Sample?
A lot.
Sample?
The t-distribution is similar to the normal curve, except that when the degrees of freedom changes, the shape of the t-distribution changes. Degrees of freedom is a sample size minus 1. The smaller the degrees of freedom, the flatter the curve. So the area under the tails is greater than in a normal curve.
I have 180
My
degrees
impression of a
freedom.
bald eagle.
Kenny's is, what? I'm America's bird.
What? That's awful.
So have them when you're playing heads up.
That makes sense.
So then the other day we saw a turkey and I was like, what? I'm Thanksgiving's bird.
I got it back.
As a result, the 68, 95, 99.7 rule does not apply. As the degrees of freedom increases, the t-distribution approaches the shape of the normal curve. This happens quickly. When the degrees of freedom equals 30, the shapes are almost identical. So, we are going to estimate the following. So for the first one, okay, it says the critical value of t for 95%, like the critical, what is that, interval thingy, confidence interval, not critical interval, too many words, and then the degrees of freedom is 7, okay, so,
Is that what DF means?
yeah,
Gotcha.
okay, so,
Ooh, that's gonna be light.
oh, that would be my foot.
I'm not recording. I'm trying to see a foot picture.
Oh no, that was for free.
Okay, so it said, somebody tell me, degrees of freedom is 7, okay, so we come down to degrees of freedom being 7,
Gotcha.
okay, so degrees of freedom is 7. If it doesn't tell you, okay, it's n minus 1, but this one specifically says degrees of freedom is 7, so we're going to come down to 7, okay, so it would have said something like n is equal to 8, which would give you 7 degrees of freedom, okay, so then it says critical value of t for the 95% confidence interval. So we come over to, we're doing two-tail probability right now, okay? It's just we are, okay? Anyways.
Got it.
So we're looking at the top one, okay? So 95 obviously isn't an option up here, but if we did 100 minus 95, that would give us 5% or 0.05. Okay, so we come down to, I'm trying to do this while looking at the camera and my paper and all of that. So 7 degrees of freedom under the 5%, and so the answer would be 2.365. Okay?
2.365. Gotcha. So the answer 2. I lost my thought. 2.365. That's just the answer.
Why is this, what is this doing? Okay, there we go. So we write it as, come on, work today.
Go team.
T star is equal to, or approximately equal to, 2.365.
Would I be so mad if I was P hat and there was a T star next to me? I'd be like, why does he get to be so special?
My mom always has a star in her name.
True. That was. Oh, come on.
Brooke, are you stupid?
I really think that's such a cool name.
All right, critical value of T for 99% confidence interval for degrees of freedom 102. Hold on.
Are we gonna use a calculator?
Nope,
No, the guys who use 99.
don't need it. All right. Okay, so this one is degrees of freedom 102. Okay, we don't have a 102. We have a 100 and we have a 120. Okay? If it's not there, we always are going to round down. So we're going to call it degrees of freedom for 100. Okay? And then it's 99%, so we're looking at the one for 0.01. Oh, it's over here too. So it's going to be this 2.626. Okay, see it?
Yes.
So the top number is that 0.01, and then you have the 100 degrees of freedom here. Okay, great. Did it right this time. All right, so we have T star is equal to 2.626. Okay, and that is, again, because we go down to lower degree of freedom if the number is between. Okay, so that one was between 100 and 120, so we used 100.
So what happens if it's like 119? Will we still go down? We go.
Still go down. Always down.
Even if it's like 1. Okay.
All right, now you're going to need your calculator.
Yes, please. Love my calculator.
Okay, so the next one wants the p-value for t is equal or less than or equal to 2.19 with degrees of freedom 41. So let me, before I...
Oh, p-value. Oh, fun.
Is it gonna be a T test?
Close. Not a test, but no, something we haven't used in a while. All right, so...
CDF?
we haven't used it before. Yes, Taylor. All right. It is going to be TCDF. So you're going to hit second and then vars to bring up your distributions. And for me, it's option 6. Okay,
no,
TCDF.
I used this yesterday. I mean, I did something wrong. Not the T one, but I used the CDF.
Normal CDF?
I
No,
didn't
we were
use
supposed to
it.
use it.
Okay. So we haven't used it
Really?
in a while.
I think so. Wait, no. I don't know if I used it on the test.
There might have been one that it was for. I don't remember. So TCDF. Okay, so in here we do something that is really, really small. You can leave the number that's here. I've used like negative 999 before. Whatever. Just really, really big, small number. Okay. And then upper is going to be the number that was given to you. So that was that 2.19. So 2.19. And then the degrees of freedom is 41. Then you're going to hit paste and enter. And so your p-value would be 0.983.
P-value?
Yes, that's what we're looking for. The p-value comes from that. Okay, somehow I just ended up on selfie in natural light mode, and I don't know why. Wrong thing again. Hello. There we go.
So it's gonna show your face in the video?
No, it's only seeing that, but I was like, oh, that's weird.
A nice angle.
I'd go cut that.
As you should.
Like, absolutely not.
I would be so scared if I was watching the video and you never see the person and go, whoa, I'd be like,
I would love it. I would laugh so hard.
Actually, I'd be kind of living for that video.
I would watch that video like every day just to laugh.
Me too. Not that you have a funny face. Maddie. You have a
I'm
normal
just
face,
writing
don't
down
worry.
what we put in.
Oh, I should do that too because I'm not going to remember next week. Or tomorrow.
Yeah.
Why would you be doing anything though? I don't know. Maybe I just decided to do stats on the weekends. I don't. I'm kidding. I don't like stats. I would rather do chemistry. Not because I like chemistry, but because I just
Stop
feel
talking.
like I have
You
to be
should stop
behind
talking.
chemistry.
So then for the next one, is it like super different from what we just did?
A little bit, but not really. So with this one, okay, notice this is absolute value. Okay, and this is going to have to be a throwback for you, but you have an inequality and an absolute value, meaning that this is also equal to negative 2.33. Okay, so what we're going to do, because we're taking the absolute value of it, okay, when we go to type this stuff in, we basically need two values. We're going to add that area together. Okay, so if we just did this one part, it's going to give us half of it. But because there's two pieces to it, because of rules of inequalities, we have to multiply it by 2 to get our area. So it's going to officially say 2 times TCDF of, since it is greater than that value, the 2.33 is going to be our lower value. Upper value can be the 1 times 10 to the 99th. And then degrees of freedom 12.
I got this. Boom.
So then you just go do the TCDF again.
What'd you get?
What'd you get?
Oh, I got
I still don't know.
0.019.
Okay, so 0.019, and then we're going to multiply it by 2.
Times 2. I got 0.038.
Would
And
it
that's gonna
matter
be your
which one you
p-value.
did first?
What do you mean?
Like, if you did.
We're not going to put the negative 1 in. We're
Okay.
just going to account for the negative 1 by multiplying by 2.
Okay.
I think all of a sudden feel
Also-
extremely tired.
The table that I gave you, it's actually a T table. I said the wrong thing earlier.
I don't know what you called it.
I don't know what I called it either, but I know it wasn't that. All right, so assumptions for using a student's T distribution, okay? We have to assume independence.
Of course we do.
Okay, of course, these are not going to be that different than what we've been doing. It's got to be random. 10% condition. Nearly normal.
That's me. I'm nearly normal.
Unimodal and symmetric.
Taylor told me I'm not normal.
Said you're not nearly normal.
So I am normal.
It's better if you're not normal.
True. Normal people are boring.
All right, and I'm going to tell you to highlight this next thing that we're going to do.
Got it.
Just All right, so confidence intervals using a student's T distribution. Okay, so the confidence interval is going to be Y bar. Okay, so that's just the average. Plus or minus T star DF times S over the square root of N, where S is the sample standard deviation.
Okay, I feel pretty okay with this. Get to have done any actual work, so that's why I feel okay. Not that this wasn't actual, but it wasn't a problem.
I'm going to hold that for later because I'm not sure if that goes with a problem or if I just did that as an example, so hold it. All right, does everybody have this?
Having some issues with
Did you hear that?
Yeah.
Yes.
I never know if people can actually hear that because I feel like I can just because it's like literally like right here.
You're good now.
Did you hear?
It sounds really loud to me, but I don't know if it actually is.
It's like normal. Like your shoulders pops louder than that.
Okay, we'll see in my, like, it sounds louder
Yeah,
than my
'cause it's
shoulder
like-
to me because it's like literally right there.
I'm yawning.
Me too.
I'm so tired. And I'm allergies. And then I get to
You
go
are
outside.
I'm allergies.
And I get to go outside and play with the pollen kids. 'Cause, you know, they stick their hand in the ground like, hey, can I give you a hug? And I'm like, but they're so cute. I love them so much. Cold. What the heck? See, you're freezing us out of class. I knew it was your goal.
I still think it's warm.
Are you okay? I can feel comfortable. I mean, I like my hands.
I'm not as warm as I was, but I was wearing my jacket when I came in, so I probably haven't cooled off yet. All right, hoping to lure more shoppers downtown, a city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees. During a 2-month period, 44 work days, daily fees collected averaged $126 with a standard deviation of $15. What assumption must you make in order to use these statistics?
Independent.
Okay, I'm just going to say that the assumptions have to be met that we mentioned before
That sounds good.
so that we don't have to write them all.
Oh, I forgot to hit O. Okay. Nobody asked what I thought just happened.
We assumed that you lost everything.
It happened.
No, I didn't lose anything.
No.
It just it switched screens like randomly.
No, we assumed.
Mine does that to me a lot. It's very annoying. All right, we need to write a 90% confidence interval for the mean income this parking garage will generate.
Don't abbreviate assumptions.
Thank you, Brooke.
You're welcome.
Thanks for the warning.
Okay, so I'm gonna write a couple things over to the side here that we're gonna use. You are gonna need pretty much the entire space, so
Got it.
don't like write massively. All right, so how many degrees of freedom do we have?
44.
Okay, so 44 is the number of work days, so that would be n. Degrees of freedom is n minus 1, so how many would it be?
43.
Okay, 43. So degrees of freedom is equal to n minus 1. It's in the notes, but I forgot we didn't like specifically read over them. So
Yeah, I'm just gonna like write that up here.
all right, so then our y bar, okay, when you get to your calculator is going to call it x bar, but your book calls it y bar. They are the same thing. Okay. When we go to do the calculator steps, I will rewrite the stuff in the color that I'm going to do with the calculator. So my average, okay, is what? 126. And my standard deviation, so S is equal to 15. And N was 44. Okay, we already said that. And I write all of that because there's a couple different ways you can do this. And so depending on which way you, like, which method you take to do it, if you do it by hand or by the calculator, I'm going to show you both just so you have it. But you would need different pieces from that stuff that I just listed. So for the 90% confidence interval for this, okay, we're using that formula that we had on the last page at the bottom, the
We're doing
y
it by
bar
hand
plus or
first?
minus t, what?
We're doing it by hand first.
Yes, I'm going to do it by hand first, and then I'm going to write underneath of it the calculator stuff. All right, so using that formula that we highlighted, okay, that's why we highlighted the formula so that you can see it. We have 126 plus or minus. Now we need to go back over to that t table, okay? The T star DF, okay, we're looking for the T value for the degrees of freedom being 43.
So we gotta go down to 40 because
Okay, yep, because 43 is not on there, okay, but 40 is, so you're going to go find 40 degrees of freedom,
1.684.
okay,
Yep.
and then your 10% is going to be that, so in that second column, so like you said, 1.684, and I would just note here that it's the degrees of freedom for 40, just so that you would know if you go back to look like later studying or whatever, you would know what it came from. Okay, times s over the square root of n. So s is 15 over the square root of 44. Okay, and then you could work it out by hand, blah, blah, blah. If you do that, you're going to get, okay, you're still getting an interval. So it would give you 122.2 and 129.8. Okay, so if you typed all this stuff in your calculator, did one being plus, one being minus, those are the two values you'd get. Okay. You can check me if you want, or you can just take my word for
I really
it.
just believe you.
I believe. It's not that I don't believe you. I just want to get it so that I can do it like in my like actually do it.
It's because she doesn't believe you.
No, I just want to know how to do it.
No. It's because she just doesn't trust her stats teacher, right?
All right, so I'm going to write over here the steps that we're going to take. We're going to be using now a t interval. Okay, so up to this, we've been using like 1 prop z interval, 2 prop z interval, the z test, all this other stuff. Now we're using a t interval. So you're going to click on your calculator, stat, then test, and then you'll click t interval, which I believe is number 8 if you were to just want to skip straight there. But not that that's super relevant. So
Input data and stats.
So we click stat, then you're going to arrow over to test, and then you are looking for that T interval. So it is number 8. So then there's 2 options here, okay? One option is to enter data, and you're going to see it's going to ask you for a list and a frequency and all that stuff, okay? Sometimes your book will give you data that you need to input into a list first. This one has given us the statistics, so we're going to click stats, and you're going to notice your options are going to change, okay? So now we're going to use this stuff. So I'll type everything, and then I'll go back and I'll write it in the video. So click the stats. In the X bar, okay, which like I said was our Y bar, your calculator just calls it X bar, doesn't matter. That's going to be your 126. Oh, not 12,000 or 1,200. The standard deviation is 15. N is 44. And we're told 90% confidence interval, right? And then you just hit calculate. Okay, and it's going to bring up your interval, and it's going to tell you all the stuff that you had put in just to verify it for you. But you'll see we got the same numbers there as if we had done it by hand. Okay, or Maddie that did do it by hand for us. If I can click the right thing this time. Okay. So we have the T interval. Okay, so we click the stats button, then it was 126, okay, like I said, this was X bar on here. Your calculator writes S as S sub X, okay, so same thing, I just want you to see it. So that was 15, and then N was 44, and then our confidence was 0.9, and it gave us out the 122.2 as well as the 129.8. And if you were to do it by hand and check it on the calculator, if you rounded, okay, along the way with this, like if you rounded your numbers, could be like a couple decimal points off, so don't be like alarmed if it's not like completely identical, you know. But you're welcome to just do it on your calculator. I just wanted you to see how to write it out by hand so you'd have it. All right, so we want to explain what this confidence interval means. Okay, so we're back to the based on the sample.
No, we're not. No way, really?
I'm serious. Based on the sample, I am 90% confident.
Why do we have to start based on the sample?
That the average daily, I guess you don't technically have to put it, but it's not something I'm going to take off for. Revenue for the garage.
It does sound cooler. Don't worry.
Is between $122.20 and $129.80. So then, money. So what does the 90% confidence mean in this context? Basically, it means that 90% of all random samples of n is equal to 44 would produce intervals that contain the actual mean value or mean daily income of the parking garage. Apparently I can't spell garage. Okay, because the average is $126, and that falls between that $122 and the $129. Okay, so it's saying that 90% of the time, the mean should be in that area, that interval. Obviously, you can have, other days where it's not that may not happen, but. All right, the consultant who advised the city on this project predicted that the parking revenues would average $130 per day. Based on your confidence interval, do you think the consultant could have been correct and why?
No.
Why not?
Because his interval doesn't even include 130.
Okay, yep. $130 is not in our interval. Seems too high. Oh, there's a part F and a part G. I don't think we're going to get to that today.
No, we have 2 minutes left.
Yeah, probably not. All right, well, we'll just call it there, and then we'll just pick that one up on Monday.
So you know what I did today, guys?